Modeling motion. You throw a ball straight up from a rooftop 160 feet high with an initial velocity of 48 feet per second. This formula describes the ball's height above the ground, h, in feet, t seconds after you throw it. So h is height above the ground in feet and t is time in seconds. The ball misses the rooftop on its way down and eventually strikes the ground. So sketch a picture. Alright, this is the building. We're up here up top. I do stick hand figures. That's a ball. The ball is thrown up and then it comes down. And it hits the ground. Okay? Now, how high is the ball in 0.5 seconds? Well, how high? That's the h. So we want to know if t is equal to 0.5, how high are we? So my h would equal, and this is another reason I store. So instead of using the t equal 0.5, I'm going to let 0.5 store in for x. Okay? So wherever I have t, I'm going to have my x value. So let me type that in exactly as I see it. So the ball will be 180 feet above the ground. Whoops, ground. When will the ball reach the ground? Well, guys, the ground, and you got to think about this, if at t equal 0.5 seconds, the ball is 100 feet above the ground, when it hits the ground, your h would be 0 because it's not above the ground anymore. So let me get my equation, and now I'm going to set it equal to 0 to see when the ball would hit. Well, if you'll notice, I've got 16. I'm going to factor out a negative 16. It should be a minus. Okay. Now I'm going to factor that. So I've got negative 10, negative 1 times 10, negative 2 times 5. I need my signs reversed. So I've got negative 2, plus 2 minus 5. Foiling would get me back to that. Now the factors I set equal to 0 are the ones that contain a variable. So t plus 2 equals 0 and t minus 5 equals 0. Okay? This does not make sense. That's negative time. So when will the ball reach the ground? It will reach the ground. Oh, let's see. The ball will reach the ground in 5 seconds. Okay. When will the ball, it should be ball, oh no, ball's height reach 192 feet? Well, again, the h, I gotta move back up here. The h would be 192. So let me write the information down. So 192 now I'm going to take everything over to my left because I like to have my variable be positive. I think it's just a little bit easier. This problem could have been done the same way, having 0 on this side, the function on this side, and then move everything over. So if I move that one over, it's going to be a positive 16t squared minus 48t. That will be a plus I'm going to have to subtract 160 from both sides, and that would be 32. Let's factor out 16 again. Taking my 2, I've got 1 times 2, but they both have to be opposite signs. These are my factors that I set equal to 0. When will the ball's height reach 192 feet? Actually at 2 points in time. Remember that we were on this building, we threw it up, and we were 160 feet high. So there's 2 points in time that it could be 192 feet when it's going up and when it's coming back down. So since both of those are positive, it's a possibility. So that's one problem. This is modeling motion.